Click on the subscribe button and press on the bell icon to watch my all new videos.
This is Ujjwal Kumar Sen, and in this video tutorial I'm going to share with you how to find out shear stress in case of fluid mechanics. And of course there is a question asked in GATE related to this topic. That's why I'm sharing with you. Okay, so as you know, these days I'm creating videos for GATE preparation and of course to solve numerical problems. So definitely in this video tutorial I'm going to share with you what is basically shear stress and related things, what you need to know to solve the numerical problems related to this topic. So basically, as you know, tau is mu du by dy. Almost those have studied fluid mechanics little bit, even they know about this equation. But yes, only knowing this equation cannot help you to solve the numerical problem. So what you need to know, you need to know about it, about this mu. This is not friction, this is you know that in case of a solid we have friction, right? But in case of fluid we have coefficient of viscosity, or it is known as coefficient of viscosity, or you can say that it is known as dynamic viscosity. So it is having relation with two things. One is kinematic viscosity, that is denoted by nu. So how is it related to it? Because you know kinematic viscosity is equal to dynamic viscosity by density. So you know, we if the numerical problem they asked in GATE previous year, they have relate this thing with this, and they again relate with density, that is with specific weight. Basically specific weight, or no, specific, not exactly, I think they have said a specific weight or weight density. These are the same thing, right? So a specific weight equal to weight by volume. Okay, so it is also known as rho g. But they have relate things with another thing, that is specific gravity. They can relate with it, but from here density and g, right? Specific gravity is equal to density of fluid by density of standard fluid. So they have relate with this density with this one to yeah, now you can see to get confused, I mean to not confuse exactly, I must not say that to confuse you, to make the problem little bit more difficulty, to increase the difficulty level. So if you are preparing for GATE, then probably you are solving previous year GATE papers, right? So you can see these examination papers or questions are really different from your university examination, because in GATE they try to relate things with each other, and that is the main problem, or you can say main strength of GATE. That's why GATE is not like that examination that you can get 100 out of 100. That's not possible in case of GATE, right? So here these formulas we are going to use in that numerical problems which has been asked in GATE previous year. I hope you are getting my point. So let's go for that numerical problem which has been asked. Okay, so right now you can see the numerical problem, and I hope you can read it, right? Because it's a very good camera. Yeah, you can read it, right? So what it said in this numerical problem, an incompressible fluid they are using. Okay, so let's write first what they have given in the question. So what they have given: incompressible fluid kinematic viscosity is 7.4 into 10 to the power minus 7 meter square per second, and specific gravity is equal to 0.88, is held between two parallel plates. If top plate is moved with velocity, okay, v is equal to 0.5 meter per second, while the bottom one is held stationary. Okay, fluid attains a linear velocity profile gap, or that means y is equal to 0.5 mm. Now between this place, shear stress in pascals on surface of the top plate. So I have to find out tau is equal to what. This is the question exactly. Well, I have already shared with you what formulas you need to implement to get the answer. I will tell you do one thing. Well, after getting all these values, I mean getting all these values given, and what to find out is not that much difficult. You can easily get out. I mean, once you will have practice, you can easily find out what they have given in the question. Now, after this step, this is the first step, pretty step. If you are beginner solving numerical problem, then this will be the first step. Okay. After solving this, you need to see what you need to find out, and based on that, I mean, what are formulas we have to find out that what they have told us to calculate from this this numerical problem, right? So we, as I have shared with you, I have made this question quite simple for you, because I have shared with you what to find out. Okay, and I have already shared with you formulas what you require to solve this numerical problem. So I will tell you, if you have been watching my videos, I have created a lot of videos for your help. Then do one thing: whenever I'm sharing with you formula, just write it down on your notebook. This will be quite difficult. Just pause the video and do it. And then what happens, write the question also, then keep doing things with me. Only watching videos can help you to understand it, but if you wanted to grab the real concept of, if you wanted to have a good approach in this topic, then you have to solve it yourself only. Then only you will have good approach. Otherwise you will come to know, you will have knowledge, but you will not have depth knowledge. So you require to solve numerical problems in the examination, you required what you required, that is important, that is what you required approach to solve the numerical problem, right? So what we have given in this question, that is tau is equal to mu du by dy. Tau is equal to mu dy by dy. So we have to find out what tau we have given. Now is there anywhere you can get mu? No. Okay, leave it then. Du we have given, that is 0.5, and y we have given 0.5. Again we have to do one thing, that is we have to notice on unit mm, so we have to convert it into meter. That's why I have to multiply with 10 to the power minus 3. Alright, so remember my dear, once again I am saying, concentrate on unit while solving numerical problem. Okay, so now what is the challenge here? That is find out this mu. This is known as dynamic viscosity. I have already shared with you, right? Or you can say that coefficient of viscosity. So for finding out dynamic viscosity, we are having a formula, that is nu is equal to mu by rho. So we can say that dynamic viscosity is equal to kinematic viscosity into density. So we have given kinematic viscosity, that is 7.4 10 to the power minus 7, but density we don't have given. So we have to find out, we have to use a relation from here. So we know that specific gravity is equal to density of fluid by density of standard fluid. Therefore we can write this equation as density of fluid is equal to specific gravity density of standard fluid. What do you mean by density of standard fluid? I'm talking about water. So specific gravity is 0.88, density of standard fluid is 1000, that means 880. Okay, are you getting my point? I hope you are getting my point. So let's get 880, we got it, density of fluid. Okay, so density of fluid is unit kg per meter cube. Okay, now we got density, we got we have to multiply this density with here. So what will get values here? I have to use calculator now. 7 multiple 4 10 to the power minus 7 multiple 880. So what we got basically 0.0006512, and its unit is Newton second per meter square. And Newton, yeah, Newton per meter square is also known as Pascal or PA. Somewhere it is written PA. If you have solved numerical problem in thermodynamics, then probably you have seen such type of unit couple of times. Even if we get Pascal in not thermodynamics, we have somewhere in thermodynamics, but if you have solved a strength of material, machine design, then definitely you have seen Pascal most of the time. Okay, so we have to put this value here, and after putting we have to do calculation, then we'll get answer. This is really simple. Right now again we need to use calculator. Multiple 0.5, the division 0.5 multiple 10 to the power minus 3. As you can see, what I am doing here, I have already written is equal to it's what is the value exactly we are getting? 0.6512. And tau, it's Newton per meter square, because all of the unit we have taken in this numerical problem SI only, that means it is in Pascal. Now check out the option we have given, that is Pascal. Okay, we have already considered this, so this one no, this one is no, this one yeah, D is the right option we have given according to the answer we got here. So now you can understand, in gate what type of preparation is required. So if you are preparing for gate, then I will share to definitely try to link with the things given in the numerical problem, or maybe in the formula. Once you will try to relate it things done, you can quite easily solve any numerical problem. This is really simple as that. Okay, so thanks for watching. See you soon in my next video tutorial. Bye bye. So welcome to this tutorial. In this tutorial we'll talk about centrifugal pump. Alright, so basically in case of centrifugal pump, what is the basic concept, what is the definition, I'm not going to share with you. You can easily read such type of definition from anywhere, but exactly what I am going to share with you, what you require to solve numerical problems related to this topic, that kind of things I am going to share with you. That means formula as well as a problem which has been asked in GATE previous year, I will share with you that thing. So there are two relations required to solve numerical problems in this case. Yeah, of course there is another relation you required, I will share with you, but that relation is not required in this question, which question has been asked in GATE previous year. So first relation we required, that is root under h1 d1 n1 is equal to root under h2 d2 n2. H is head, d is diameter, n is revolution per minute of that pump. Now second relation required, that relation is also very common. q1 d1 n1 is equal to q2 d2 n2. Here d both are same, q is discharge. Okay, now most important relation one, and the relation that is required, that is specific speed. Okay, that is for specific speed. Ns is equal to n root under q s to the power 3/4. The same relation is for I have already shared with this for turbine, but there is a difference there. S to the power 5/4 we usually read, right? So these three relations are most important in case of centrifugal pump. But the first by using first two relation, this one and this one, we can solve the numerical problems which has been asked in GATE previous year. Alright, so what you require to solve the numerical problems, first formulas, what I have already shared with you. So based on these two formulas you can solve the numerical problem, right? Now what you have to think, what you need to just go to the numerical problem, which I'm just going to share with you here. This is the numerical problem we are going to solve here, and you need to do what? You need to understand the question first and solve the numerical problem, right? So let's read the question. What we have given in this question is centrifugal pump running at 500 rpm and at its maximum efficiency is delivering a head of 30 meter. So n is 500 rpm and its head is 30 meter at a flow rate of 60 liters per second. At a flow rate of 60 liters per second, that means q is equal to 60 liters per not second, it's minute. Okay, if the rpm is changed to 1000, this is case 1. They have said this is case 1. So let's say this one n1, this is h1, this is q1. Case 2. So in case of case 2, what they said, n2 is equal to 1000 rpm. Okay, now we have to find out then head and flow rate, that is q, in liters per minute at maximum efficiency. Okay, so if the condition is changing from here to here, if revolution per minute is changing, then we have to find out h and q. So we have the same centrifugal pump. Now the first relation we can use, that is I have already shared with you, root under h1 by d1 n1 is equal to root under h2 d2 n2. Okay, we have given n1, we have given n2, we have given h1. We have to find out h2 because they have asked us to find out h. Now we don't know the value for d1 and d2. Now read the question. Is there anywhere they have shared this information? What is the diameter of that pump? No, they haven't shared. But from the question only we can understand that they are changing its revolution per minute. That means speed they are changing, right? But they are not changing the shape and size of the pump. That means for the case 2 also diameter would be same. So from these two data we can say that d1 is equal to d2. Therefore this one and this one, I mean this d1 will cancel out. So what we got here, root under h1 by n1 is equal to root under h2 by n2. Further simplification we can get the answer. So just do cross multiplication. N2 is equal to root under h2 root under h1 multiple n1. So root under h2 is how much? h2 is we don't know, we have to find out h2, right? So we have to find out h2, right? So do calculation like this. Yeah, like this calculation we have to do. h1 by h2 let's say, and n1 by n2. So just do square both side. Okay, so after squaring what we get, h1 by h2 is equal to n1 by n2 whole square. Now h2 is equal to what? h1 multiple n2 by n1 square. h2 equal to, so h1 is how much we have given? 30, and n2 is what? 1000, n1 is 500 square. So 2 square 4, 30 multiple 4 is equal to 120 meter. That means the head we are getting 120. So just cross the option we have given whose head. Okay, only one option is crossing from that answer. That means we have to find out discharge also, then only we can mark the right answer. Okay, so why I have been doing this, because I have seen many questions, they have asked to find out two things, but after finding out one thing we can get only one answer for that question. Then we don't need to solve that question further. We can mark that answer as right answer because we are having only one option. But yes, do check one thing, what answer you have find out, that should be that should maintain accuracy. You should get accurate or correct answer. Okay, now now let's go for the numerical problems next. That is, we have to find out q2 also. Okay, so we have done already h2 we have already find out. Now how to find out q2? q1 by d1 n1 is equal to q2 by d2 n2. We got the relation, but again we know that d1 is equal to d2, that d1 and d2 cancel out. So what we got from here, q1 by n1 is equal to q2 by n2. What we have to find out? q2. So q2 is equal to q1 by n1 multiple n2. Therefore q1 is how much? 60, and n1 how much we have given? 500, n2 is 1000. So this one got 2. So 60 multiple 2 to 120 liter per minute. Okay, so q and h both are same. Now find out the option, which option is just just correct for that, for the answer we have find out, right? So option C is the right answer for this question. Now let's review it again. That's why you will understand what exactly you need to find out, right? Now in case of centrifugal pump, I have shared with you that these three formulas are most important, and based on the first two formulas we got a question which has been asked in GATE previous year. Okay, and the next one is quite important also, because I have already shared with you a question which has been asked from turbine and Francis turbine. Okay, so based on that data I must share with you, this is ns is specific speed. And yes, if question they will come in the examination, then probably this one is also important to find out its answer. All right. So basically, yeah, one more thing. It is a dimensionless quantity. Remember that specific speed is not having any dimension. Okay. So you also need to remember that. So what you got basically from this numerical problem, that what are most important formulas of centrifugal pump first. Second, other than the formula we have used in the numerical, I have also shared with you one extra formula. Second, third, a formula, a numerical problem which has been asked in gate, we have solved in front of you. For solving this numerical problem, what you required basically, those two relations first, and second, how to implement those relation in the numerical, by using the data we have given in the numerical problem. So after implementing, we got the right answer. Okay, that's the right answer because I have already checked. So in this problem we have learned many things. I hope you also learned something, but what you have to do, you have to practice based on those formulas few numerical problems, probably previous year or from any book or anywhere. You need to practice, otherwise you will forget those formulas. Okay, so thanks for watching. See you soon in my next video. 12. Bye bye. This is Ujjwal Kumar Sen, and today we are going to talk about turbine. Well, this video tutorial is only dedicated to gate problems, gate numerical problems, or if you wanted to learn to solve numerical problems, then this is the tutorial for you. So in this tutorial I'm going to share with you a problem which has been asked in gate from turbine only, and few necessary things those required to solve that numerical problem. So first of all, I will talk about formulas, then I will talk about some basic concept, then I will definitely go for that numerical problem. So to we required two formulas to solve numerical problems. That which numerical problem they have asked in gate. One is specific speed, which is denoted by ns, and ns is equal to, its formula is little bit it will make you confused with the pump, maybe blower, or maybe compressor or fans, even you can say that. But here ns is specific speed, n root under p is power, h is head, n is revolution per minute, and this specific speed is having no dimension. This is dimensionless, remember that. And one other thing we have to do, that is power is equal to rho g h q. This is the simple formula which probably you have used in case of flow through pipes problems, if you have solved numerical problems related to that topic. Okay, so these are two things you require to solve the numerical problem which has been asked in gate. But these are not good enough. You have to find out, you have to also need to know the specific speed for turbines, right? So if you're talking about Pelton turbine, its specific speed is about 10 to 30, 35 or 30. Its specific speed is like this. Now if you're talking about Francis turbine, it's around 62 to 80 or 300, right? And if you're talking about Kaplan turbine or propeller turbine, they are having maximum specific speed, just like 280 or 300 to 1000, you can say. Okay, so these are three types of turbines we are using these days, and yeah, it's specific speed here. So based on these data we can solve that numerical problem. Okay, so that's why I'm sharing with you first what you require to solve the numerical problem, then we will go for that numerical problem. That would be quite easier, quite helpful for you, which is experimented by me even. Okay, so let's go for that numerical problem which is much more required here. So what happened, now we have the question in front of you. So in this question what they have given, at a hydroelectric power plant site, Available head and flow rate are 24.5 meter and 10.1 meter cube per second. So what they have said, head is h is equal to 24.5 and flow rate q is 10.1 meter cube per second respectively. Okay, it's discharge basically. After looking at the unit, you can say this is discharge, right? If the turbine to be installed is required to run at this much per second, so they said n is equal to 4 revolution per second, so we have to change into minute, therefore I will multiple with 60 is equal to 240 rpm. Alright, now what we got, head we got, q we got, n we got. Okay, okay, now let's go for it. With an overall efficiency is equal to 90%. This is also matter. Now based on this data, what we exactly required to tell that what type of turbine actually this system is working. So for that we need to find out ns we have to find out, that is what, and a specific speed we have to find out for finding out the what type of turbine actually we have. Okay, based on the head we can say, but here we cannot say based on the head, because based on the head if you can say, then it's it's Kaplan or even propeller turbine we can say, but it's not based on that. Okay, so first we have to find out ns. We have to find out ns, right? So for finding out ns, I have shared with the formula, that is n root under p s to the power 5 by 4. We have n, we have h, we don't have p, right? So first of all we have to find out p. P means power equal to what? Rho g h into q. Let's say it's capital H. Density of, it's a hydroelectric pump, so water is talking, we are talking about water, 9.81, head is 24.5, q is 10.1. okay. So let's do calculation. 1009.81 multiple 24.5 multiple 10.1. so what we got values basically here, and let's do calculation again. 1009.81 multiple 24.5 multiple 10.1. yeah, one other thing I'm missing here, that is efficiency. We have to multiple efficiency here also, that is 0.9. so 0.9 I have to multiple. What we got basically 21,84736.05. so it's 21,84736 kilowatt. Okay, kilowatt. Now one more thing I haven't shared with you, that is, if you are talking about turbine, in case of turbine, if you wanted to find out specific speed, then n root under p power, that power should be in kilowatt. Here you can make mistake, because power should be in kilowatt. You should not change this. Kilo should not be written here in multiple 10 to the power 3. If you will do that, then you will not get the answer, but because that is not that is not required, right? So what is basically required here, this should be kept in kilowatt. That means I will write this value only, I will not take this kilo into consideration. Okay, let's write first, then you will understand. N is what we have find out already, 240, power 2184.736, that's it. Now H 24.5, 5 by 4, right? So in this way we can solve it. Now what we have to do, we have to use calculator. 240 multiple 2184.736, its root, division 24.5, 5 divided 4. Okay, so how much value basically we are getting? 80. yeah. And one more thing, this is dimensionless. I have already shared with you that a specific speed is dimensionless quantity. Okay, so the specific speed we are getting 205. That means based on the data I have provided already, you can say what type of turbine we have, that is front sister turbine. Okay, so this is what the answer is. C, option C is the right answer. Now after solving this problem, you can understand that what we require to solve the numerical problem. First, understanding the basic little bit. Second, we required formulas, and third, we need to understand what to implement. And that kind of approach you can build easily if you solve few problems related to the topic. Just like here, you can make mistake, and this mistake only will come to know that there you can make mistake after solving numerical problems. So what is the key? That is, you have to understand its basic, as well as you have to know what to do and what to implement in the numerical problems. That is the key to get success in GATE like examination or to solve numerical problems right away. Even in the university examination, you will get this type of problem. Probably you will get this type of problem for 10 marks or even 15 marks, maybe 5 marks. That definitely these formulas will help you a lot to solve the numerical problems. It's really simple. Okay, so thanks for watching. See you soon in my next video tutorial. Bye bye. And if you like the tutorial, share it with your friends. Thanks. So this is Ujjwal Kumar Sen, and in this video tutorial I'm going to share with you how to find out maximum discharge. Well, I have a question. That question has been asked in GATE previous year. That means in this tutorial you will going to learn how to solve numerical problems, as well as formulas you need to have in your mind to solve or to find out maximum discharge. So let's go for the formulas. So basically 3 formulas you required as per the question requirement, and this question already asked in GATE, I think 1 or 2 marks, right? I couldn't remember for how much marks they have asked, but yes, I actually noted down the question. Definitely I will share with you. So the first formula we require, that is continuity equation. One more thing, if you are preparing for university examination, then I will definitely share with you one thing. You should remember or should understand the derivation of continuity equation for Cartesian coordinate as well as cylindrical coordinate, because both of them are most important. That is, a1 v1 is equal to a2 v2. And then Bernoulli's equation. What is about this equation? Bernoulli's equation is P by rho g plus v square by 2g plus z1 is equal to constant. We can say z also, right? Next is discharge. What is the formula for discharge? Basically, we denote discharge by Q. Okay, and the formula for discharge is a1 v1 or a2 v2, but here we are talking about maximum discharge. So if it is, the diagram is like this. Okay, suppose that this is 1 and this is 2. We are using reducer, then definitely discharge will be maximum here. So we'll go with the a1 v1 for finding out maximum discharge. What I am sharing with you, the same question has been asked in GATE previous year. I know this question is a little bit lengthy, and probably it will take 10 to 15 minutes to understand and to share with you. But definitely you will understand the whole concept, what you required, if you will get question related to it in the upcoming examination. Alright, so let's go for that question. So we have this question, and I hope you can read this question. It seems really lengthy question, and of course it's a lengthy question. So in this question, what they have asked, basically, consider steady incompressible irrotational flow through a reducer. Okay, so first of all, draw a reducer. Suppose this is 1 and this is, so no, this is not a reducer, this is a reducer, right? This is 1 and this is 2. Okay, now suppose that this water is flowing like this, or fluid is flowing like this. Horizontal pipe is there. So remember this one, horizontal pipe. Horizontal pipe means Z1 is equal to Z2. if you are equating to both sides, condition 1, condition 2, and implementing Bernoulli's equation. Okay, you will understand right now only. Per diameter reduced from 20 centimeter to 10 centimeter. Always remember unit play most important role, right? Just upstream reducer is 150 kilopascal, and fluid has vapor pressure is BP is 50 kilopascal, which is must be equivalent to this one, P2. And specific weight is equal to 5 kilonewton per meter cube. Okay, this is also known as rho g, which I have used in that equation, Bernoulli's equation, right? Neglecting frictional effects, maximum discharge that can pass through reducer without causing cavitation. Okay, that means if it is without causing cavitation talking about, that means definitely this side would be vapor pressure only, right? Now what we require, basically we need to find out Q max is equal to A1 V1. A1 is pi by 4 d1 square, d, that is d1 square, d1 is 20 square multiple 10 to the power minus 2 definitely square into V1, right? Now we don't know V1, what is V1 we don't know. So by implementing Bernoulli's equation, we can find out the value of V1, because we have given all these here to implement and to get an answer, right? So here what pressure we getting 150, and here 50 pascal we are getting. So Bernoulli's equation, P by rho g plus V1 square by P1, let's say 2g plus Z1 is equal to P2 square by rho g, sorry, P2 by rho g plus V2 square by 2g plus Z2. Z1 and Z2 get cancelled. Okay, now what remaining, basically P1 by rho g plus V1 square by 2g plus P2 is equal to P2 by rho g plus V2 square by 2g. We'll send this to this side, so P1 by rho g minus P2 by rho g is equal to V2 square by 2g minus V1 square by 2g. Get common here 2g, so V2 square minus V1 square, and here P1 minus P2 by rho g. Okay, so what is the value of P1? 150 minus P2 50, P1 minus P2 by rho g is, here we have given specific weight is 5, so we got value till now here. So V2 square minus V1 square by 2g, so this is 100 by 5 multiple 2 multiple g is equal to V2 square minus V1 square 1, so V2 square minus V1 square is equal to 20, 40 multiple 9.81. okay, 40 multiple 9.81. I hope you can see. Yeah, now thing is that we don't know the relation between V1 and V2. Once we'll come to know the relation between V1 and V2, like definitely we can solve the problem, right? Now it's time to implement the third formula, which I have already shared with you, right? So what about that third formula? That is continuity equation. Continuity equation. So what is stated that A1 V1 is equal to A2 V2. So A1 pi by 4 d1 square into V1 is equal to pi by 4 d2 square into V2. So pi by 4 get cancelled. D1 is how much we have given, that is 20 square. Don't need to check unit because both sides we are having same unit, 20 centimeter 10 centimeters, so we'll get answer in any unit we wanted to, right? So 20 square and 10 square 2, so V1 400 100 multiple V2, so this we cancel 4 V1 is equal to V2. So what we can do, basically we got the equation from here, that is V2 square minus V1 square is equal to 40 multiple 9.81. Now in place of V2 we can put this value, right? So what we got, 16 V1 square minus V1 square is equal to 40 multiple 9.81. 16 minus 1 15. So V1 square is equal to 49.81 by 15. So we have to find out V1 is equal to root under this term 40 multiple 9.81 by 15. Just to use calculator, divide by 15 is this, its root we have to find out. Don't forget to find out root, right? So we find out 5.11 meter per second V1. Now we have to find out what here we have to write 5.1 in place of this. Now use calculator to calculate this term. So 20 multiple 10 to the power minus 2 is 0.2. Our whole square is this, and V1 5.11. We got this multiple pi divided by 4 is equal to how much value? Basically we are getting 0.160 and 160.5, right? So it is only 2 they have given 0.16 meter cube per second discharge. Now check the unit we have given in this problem. We got the answer is 0.16. So we have given options 0.38, 0.27, 0.16. So option third is the right answer according to our calculation. Now I hope you understand how we have implemented these three formulas to find out maximum discharge. Okay, I hope you understand the question, how to solve it, and hope so it help you a lot, and it will definitely help you in the examination, upcoming examination, as well as university examination, definitely in numerical problems, right? So thanks for watching. See you soon in my next video. Bye bye. And here, so this is Ujjwal Kumar Sen, and in this tutorial we'll learn about how to solve numerical problems, especially those asked in GATE previous year paper, through in this topic only. So if you're preparing for GATE 2017 or maybe upcoming examination 18 or any examination, right? So for solving problems related to venturi meter, as I have seen question, you require two formulas. Yes, what I am sharing with you, you require two formulas, and these formulas are most important. Probably you know those formulas, but implementation of those formulas is the key to get success. Yes, to get success means to get the right answer of the question. So those are continuity equation, and second is Bernoulli's equation. If you know these two equations, then you can easily find out a problem related to venturi meter. Well, I have already shared with you derivation of continuity equation as well as Bernoulli's equation. But yes, in this tutorial I will share with you how to solve numerical problems related to this venturi meter. Okay, so as I have asked many of my friends, those have prepared for GATE for several years, those even scored about 60-65 marks in GATE previous year. So I've asked them what is the pattern of their preparation. They told me the same pattern what I am sharing with you. They always go through the topic and they always solve numerical problems, because in GATE 80 to 90% questions are numerical based. So you should focus on numerical, but you must know the formula and little basic concept. That's why you can solve the numerical problem. You can understand things what is in the numerical. Okay, so what is basically continuity equation? That is a1 v1 is equal to a2 v2, and this Bernoulli's theorem, p by rho g v square by 2g plus z is equal to constant. Therefore we can say like this also, p1 rho g plus v1 square by 2g plus z1 is equal to p2 by rho g plus v2 square by 2g plus z2. We can do like this, right? Now one thing is clear in this question, what question I am going to share with you, there I will use only these two formulas. Yes, but the way I will implement, that is matter. You need to understand that pattern, how I am implementing these formulas, because only remembering formulas not going to help you. You need to understand the pattern, which pattern I'm implementing to solve the numerical problem. Alright, so let's go for it. So I have question, and I hope you can read this question which is right now in front of you. So according to this question, what they have given, there is a venturimeter of 20 mm throat dia. So as a basic diagram of venturimeter, let's go for it, and suppose that it's a throat dia. Okay, 20 mm, right? Yeah, unit play most important role. So if you're preparing for gate, don't forget to notice unit. In every question you have to notice unit to get the right answer. Now we got this one. Now they said dia is used to measure velocity of water in a horizontal pipe. Okay, this is a key, my dear. This is a key, horizontal pipe of 40 mm dia. Okay, suppose that pipe dia is 40 mm. If pressure difference between pipe and throat section is found to be this. So they are saying that pressure difference between pipe and throat is this. So let's say P1 minus P2. Okay, we can do that. P1 minus P2 is 30 kilopascal. Okay, neglecting friction losses, that means head loss and all that, we have to neglect it here from neglect from this question. And then flow velocity, we have to find out flow velocity, that is we have to find out V1. What is V1? Okay, so for finding out V1, what we have two formulas, but most important formulas is the Bernoulli's equation that state that P by rho g, let's say P1 plus V1 square by 2g, because we have in two section here, section 1 and section 2, plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Because this is a horizontal pipe, it is stated that horizontal pipe, that means Z1 is equal to 0, Z2 equal to 0. Okay, we are cancelling this. I mean, we can cancel Z1 and Z2 because both are same. So what we got here, we just send this one to this side, this one to that side. Okay, so what we got here, P1 by rho g minus P2 by rho g is equal to V2 square by 2g minus V1 square by 2g. Okay, now let's take LCM. Rho g P1 minus P2, and here LCM 2g V2 square minus V1 square. So g get cancelled. Again we know that P1 minus P2 is 30 kilopascal. So 30 10 to the power 3. Density is what? 1000. Density of water is 1000, right? Now what we got here, half V2 square minus V1 square. Now what we required, this one get cancelled. So what we got basically here, 30 is equal to half V1. So 30 multiple to 60 V2 square minus V1 square. Okay, so if we have to, our ultimate aim to find out is V1 is what? Our ultimate aim is here. Now we have to find out what is V2. What is V2 we have to find out. If we'll find out what is V2, then we can solve the question quite easily. Now I have shared with you another relation that is known as continuity equation, that A1 V1 is equal to A2 V2. Right, so A1 means area pi by 4, cross sectional area of this circular section, so D1 is square, into V1 pi by 4 D2 square into V2. So pi by 5 by 4 get cancelled. Okay, so D1 is how? 40 square plus V1, and D2 is what? 20 square multiple V2. So V1 by V2 send this side, 20 square by 40 square, that means 1 by 4. So relation is V1 is equal to, V2 is equal to, we can say 4 V1, right? Now put this value V2 here. If I will put this value V2 here, so what we got basically 4 V1 square minus V1 square, right? So 60 we got it here is equal to, let's say V1 square 16 minus 1, that means what exactly we are getting here, 15 V1 square. Okay, let me write yeah, I got a space here. So what is the equation actually I'm getting? I'm getting here 15 v1 square is equal to 60. So v1 square is equal to 60 by 15. Okay, what I have done, I have just taken this equation to this side because I got space here, right? Now 64 4, so v1 square is equal to 4, v1 is equal to root under 4, it's 2, right? Now 2 is what? It's meter per second. Now one thing I haven't shared with you here, I must see that is, you know, v1 and v2, and here we're getting 4. I haven't changed its unit because both side we got both side got mm square, so there is no difference because we getting mm square get cancelled, so we can get meter per second there. That's why we don't need to change the unit. That's why I have shared with you in the beginning of the tutorial that unit play most important role. So I hope you understand this question, and as I have shared with you, this is the question of Venturi meter, and in this question what we required to solve the problem, those are continuity equation and Bernoulli's equation. Well, if you are preparing for university examination, then I will definitely recommend you just do these two equations because these two equations are most important. These two equations are most important. In general, they have asked question from these two equations. That's why even I have shared with you its derivation. And for continuity equation, you should go for both the equation, just like rectangular coordinates or Cartesian coordinates, as well as cylindrical coordinates. Okay, so those equations are most important. So I hope you understand something from this video tutorial about Venturi meter, and the previous year portion definitely help you a lot to understand and to build basic approach to solve questions related to GATE. Well, best of luck for your examination, upcoming examination. Thanks for watching. See you soon in my next video. Bye bye. So in this video tutorial, you are going to learn about how to derive continuity equation for cylindrical coordinates, right? So no more time, let's get started. Make this diagram a little bit bigger, that's why there would not be any hodgepodge, right? It's 5, this is 5, this is UC, this side UC, curly UC by curly, this direction is R, and this is delta R, and this side I'm taking U5, therefore here U5 plus curly U5 by curly in this direction, 5 only, so R should be here, multiple R del 5. Okay, this is about the diagram, and this is known as phi angle. Okay, so this diagram is most important for, you know, for continuity cylindrical coordinates. This is cylindrical coordinates we are taking, and just follow my step and keep doing by yourself also. Take a pen and a paper and just start doing derivation, because only watching derivation cannot help you to definitely can help you to understand it, but if you wanted to do derivation in the examination, then you have to practice, you have to derive it yourself at least twice or thrice, then only you can able to derive in the examination. Okay, because my videos will not be there to help you, so you will be there only, so you are the one who need to understand all things, right? So let's get started. So what happened if I am seeing mass flow rate entering radially, okay, radially, and here radius I am taking as R is equal to UC rho R curly phi curly z. Okay, now if something is entering and it is an open channel, then definitely something would be leaving, so I can say mass flow rate leaving radially at radius R, you can see, right, is equal to what will happen. Now here is the thing you need to understand. If something that is entering, and then definitely something is leaving, but here radius is R plus del R, or not only R, because there is small part I am taking considering here, a small part. The small part is known as del r. So what will happen in this case? UC curly UC curly r del r multiple rho r plus del r curly phi and then curly z. Okay, now you can clearly see the differences between this equation and this equation. That's because of here and here. Okay, so this is about the equation, and now what we have to find out, it's net flow rate or net things are remaining in this control volume, I can say. So before going to do that, just do multiplication of these things, because here I am getting a lot of things to multiply, right? So this is a multiplication, so it takes time, and of course it takes for you, and it will take time for you to understand the whole things also, right? So first of all, what I am doing, nothing about it, we'll get 4 terms here. Okay, just multiple UC with this one. So UC rho r del phi and del z. So here what will get them? UC curly r del r, the same thing I am writing here. Yeah, so the same thing I am writing here then, and rho r plus del r curly phi curly z, right? Now again we have to multiply. We will get 2 terms from here, we will get 2 terms from here. So what exactly we are getting? Rho UC, right, r curly phi curly z plus rho UC del r curly phi curly z plus curly UC curly r del r, then del phi, then del z, then rho, then r, plus you can say curly UC curly r del r del phi del z rho, and definitely there not be r because there is only one r. So now think about it, here all these small terms, because of these small terms, if I multiple 0.1 then this will become more smaller, right? So because of this term is quite small, this is really small, that's why we are neglecting this term and we are considering all these 3 terms. Are you getting my point? Because this term is quite smaller, that's why. Now if you are thinking about net mass rate leaving in the radial direction, so we have to find out, let me use another piece, right? So we have to find out net mass rate leaving in the radial direction. Okay, so we have to find out this only. So here is it, UC rho del r del phi and del z plus curly UC by curly r rho r del phi del r and del z. So this is the thing we have written already. Now how I am getting these things, that is what exactly I am doing. I'm just let's say this equation is equation 2 and this is equation 1. So exactly what I'm doing equation 2 minus equation 1. After doing this, I'm getting this thing. Are you getting my point? Now this is really important. This thing don't require, just you need to, what you need to do, you need to subtract. Now look at the common terms we are getting here. We're getting common terms here as this and this, right? And we can say curly phi, curly r and curly z is curly v. Okay, total volume we can say that. So just write rho curly v UC curly r rho r, this is the thing we are getting. Now we can get outside, what we can get these things common also. So rho curly v UC curly UC by curly r into r. So this is the thing we get in case of what direction? In case of direction, that is the radial direction. So radial direction we are getting this, right? Now think of yourself. We have done equation for only one direction, that is radial direction. Now what we have to do? Now we have to do similarly for phi direction as well as z direction. We have to do equation for other both equation. So let's go for it. Similarly phi direction, what we will get? For phi direction we are getting here u phi plus curly u phi by r curly phi, then r del phi, right? I have to multiple this way, rho curly r and curly z minus u phi curly del r del z. So what exactly we are getting here? 1 by r curly u phi curly phi rho del v. Okay, because this one and this one get cancelled, so we'll get this one only. Now I can say for z direction what exactly we are getting. If we'll get z direction we are getting here uz plus curly uz by curly z del z, right? And here rho del r multiple r del phi minus uz rho del r multiple del phi. Now what exactly getting? See, like this, here what happened, this one and this one get cancelled, here also this one and this one get cancelled. So what we'll get here, curly uz by curly z rho delta v. Why it is happening? Because I have already shared with you this thing we are considering here, right? That means del phi del r and del z is equal to del v. So because of that we have done this here also, and here also we have done this. Now what we have to find out, net efflux across the cylindrical control volume is 0, because we know that. So we can say net efflux across the cylindrical control volume is 0. So what we can write, uc by r curly uc by curly r rho del v 1 by r u phi by curly phi rho del v plus curly uz by curly z rho del v is equal to 0. So we can send, we can get common and send that side. So what will you get, uc by r plus curly uc by curly r plus 1 by r curly u phi by curly phi plus curly uz by curly z is equal to 0. So this is the equation we got, continuity equation for the case of cylindrical coordinate. Of course I have shared with you already how to find out continuity equation for Cartesian coordinates in my videos, and definitely that one is more simpler than this one, cylindrical coordinate. So if you are preparing for your university examination, then for this cylindrical coordinates is also important, and of course it requires time for deriving the equation. I hope you understand, and it will help you to get good marks in the examination. Best of luck for examination. Thank you very much for watching, and thanks a lot. Bye bye. My dear, this is Ujjwal Kumar Sen, and in this video tutorial I am going to share with you how to derive continuity equation for Cartesian coordinates. Well, probably you have seen this as rectangular coordinates, right? Because Cartesian coordinates is also known as rectangular coordinates. That's why I have seen in many books they have told this as rectangular coordinates. That's why I'm sharing with you. So in this video tutorial I'm not going to tell you anything else other than the derivation. So just keep listen to me, and do one more suggestion. As you are watching this video, keep pausing this video and do derivation by yourself also. This will not only help you to understand the derivation, also help you to remember the derivation and steps you need to follow to derive the equation. This is the simple way. Only watching this video is definitely going to help you, but yes, that's help you. If you wanted to get full advantage of this video, then just keep watching and keep doing what exactly I am doing to understand this derivation much better way. So let's get started. First of all, we have to draw a Cartesian coordinate, right? So that is important, and in this coordinate system we'll have three coordinates. Okay, so this one must be y, this one is x, and this one is z, right? So here what is happening, basically we are saying this is a, this is b, this is c, this is d. Let's say e, f, g, h. So suppose that through this x direction u velocity, it is water is flowing or something fluid is flowing with this direction is u. Therefore the out velocity would be u curly x dx is across one little bit area. Okay, in this direction we are taking v, and therefore will happen v curly v by curly y because of y direction, and in this direction we are taking top w. Therefore w plus curly w by curly z multiple till z. This is a simple concept you need to remember, right? I mean, just you need to remember u, v and w we are taking because of three directions are there. In this control volume we are going to find out its continuity equation, right? And now what is happening basically, so what is happening, we need to find out mass rate entering through ABCD phase, you can say. So ABCD, look at this ABCD phase, ABCD phase, mass and mass rate is entering, rate is there, that's therefore that means they are in this equation we are we are relating things with time also. So it is density u del y del z. Okay, suppose that this is equation 1. Now exit, there should be something exit, that is we can say this mass rate exit through phase EFGH is equal to rho u plus curly u by curly x del x. Then next what will happen, what we have remaining del y del z, for this is equation 2. Now exact if I wanted to find out net mass rate living in x direction, and these two things we are considering for this direction only, this x direction. You can see this exit, this is entering, this is exit in the x direction. The same way we have to find out in y direction as well as in z direction. Are you getting my point? So what we have to find out, that is net mass rate living in x direction. So what we have to do, we have to do one thing, equation 2 minus equation 1. Simple. Now write down this equation 2, density u curly x del y and del z minus rho u del y and del z. Now do little bit multiplication over here, that's why we can simplify this equation further, right? So rho u curly y del y del z plus rho del curly u curly x del y del z minus curly u del y del z. Then what will happen, this one get cancelled, both cancelled out. So what remaining here, rho curly u curly x del y del z. So what we got here, rho curly u by curly x del v we got here, and this is in the case of only x direction. remember that. Okay, now if you have simultaneously, you can say what will happen in case of y direction. That is also important. So we don't need to go through all these steps, because we have already shown how to find out net mass rate leaving in the x direction. Now we have to find out net mass rate leaving in the y direction is equal to what you can guess, rho curly v by curly y del v. Okay, this is for y direction. Now if I say net mass rate leaving in the z direction, then rho curly w by curly z into del v. So we have find out net mass rate leaving in x direction, in y direction, as well as in z direction. Now if I wanted to find out total mass rate, then what I have to do, just write down net rate of mass leaving in the control volume. So here, what is the meaning of control volume? Here control volume means this rectangular coordinate or Cartesian coordinate. So what exactly we are doing is equal to, so in x direction how much it is leaving first, plus in y direction, okay, plus in z direction, right? We have to add all. So first of all we have to write rho curly x and it's not u curly u, it's x into curly x and v, plus rho curly v by it's volume basically, so curly y del v, and plus rho curly w by curly z multiple this. So what exactly we are doing here, that control net mass rate across constant volume should be 0. This equal should be 0. So we should have to write this. Now in case of incompressible fluid, that is rho is equal to constant. Remember that in case of incompressible fluid, rho is constant. So further we can write this equation as like this: curly u by curly x, curly v by curly y, plus curly w by curly z is equal to 0, and this equation is known as continuity equation for Cartesian coordinate. Now one thing, this equation is valid. Now where this equation is valid, okay, in case of steady or unsteady flow, I mean this equation is valid for both steady flow as well as unsteady flow. So this is the equation for continuity equation for Cartesian coordinates. Well, in my upcoming videos you are going to get continuity equation for cylindrical coordinates also. Yeah, that's really also important important derivation, I must say that, if you are preparing for university examination. Well, that's all about continuity equation for Cartesian or rectangular coordinates. So don't get confused there, because Cartesian coordinates and rectangular coordinates both are same. Okay, so I think you have learned something from this video tutorial. Thanks for watching. See you soon in my next video. Bye bye. So this is Ujjwal Kumar Sen, and in this tutorial I'm going to share with you how to find out head loss using Bernoulli's equation. And I hope you know what is Bernoulli's equation, right? Because I have already shared with you the derivation of Bernoulli's equation. So what is basically Bernoulli's equation? That is P by rho g plus v square upon 2g plus z is equal to constant. Basically this equation we can derive from Euler's equation quite easily. Just we need to integrate that equation, then we'll get this value. Alright, So basically head loss using Bernoulli's equation we have studied in fluid mechanics, and I'm sharing with you this topic because in GATE they have asked question related to this topic. So basically what you have to do in that question, you have to use this formula. This is a basic concept to solve that problem, right? So by using this formula you can solve the numerical problem quite easily. I'll share with you how to solve that numerical problem, as well as I'll share with you about that question, right? So basically what you have to do in that question, that is P1 by rho g plus V1 square upon 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus h. You have to find out this h. This h is known as head loss. Alright. So here in case of Bernoulli's equation, this head loss is because of elevation, elevation, or must say that arrangement of that pipe, okay, location of that pipe, because of that head loss is happening. Okay, so from this is the formula we are going to use in that numerical problem to solve and to find out head loss. Okay, so this is all about the equation of Bernoulli's equation and head loss. Well, if you are preparing for university examination and with that you wanted to prepare for GATE examination, then Bernoulli's equation derivation is also important with Euler's derivation, Euler's equation derivation. That's why I have also shared both the derivations in one of my video tutorial. Okay, so I will suggest you to watch that video tutorial to understand its derivation also. Now let's go for that numerical problem which has been asked in GATE previous year. So here is the numerical problem. What actually asked in this numerical problem, they have asked a smooth pipe diameter of 200 mm carries water. Okay, that's fine, and the pressure in pipe at section S1, elevation 10 meter, and pressure is 50 kilopascal. So the diagram is like this. Okay, suppose that this is this. They are saying the elevation is here, that is 10 meter, and the next elevation is 12 meter. So this is 12 meter, right? Suppose that this is S1 and this is S2 according to the question. They said at the elevation at 1, and here this is 1 and this is 2. In this one they said that 50 kilopascal is pressure, so P1 is 50 kilopascal, and S2 elevation pressure is P2 is 20 kilopascal. That means clearly it is showing there is a decrease in pressure energy. Alright. Now velocity, they said velocity is 2 meter per second. There is no change in velocity in this question, they have said already. So density is equal to 1000 kg per meter cube. That means water is flowing through the pipe. Alright. Now acceleration due to gravity, that is not okay, that's not required, but even then it is meter per second is square. Even then they have provided this, right? Now which of the flowing is true? So they have given statement in this question. So what are statements we have to just go through? That is, flow is from S1 to S2 and head loss this much. Flow is from S1 to S2, and flow is from S2 to S1, and flow is from S2 to S1. So now we don't know from here it is flowing, okay, but yes, we have to find out if we'll get positive value of S, that means flow is from S1 to S2. If we'll get negative value, then S2 to S1. That is the thing we can understand, right? But it is in general, if S1 to S2 is water is flowing, that means they definitely had loss because of this elevation by 2. Okay, this is a simple thing. Now as I have already shared with you what formula we have to use, that is Bernoulli's equation. By using Bernoulli's equation we can easily find out its head loss. So first of all we will go for that formula. So what about that formula? That is P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus H. This H we have to find out from this equation, right? But here velocity is 2 meter per second, both the velocity is same, so this will become both the 0, because both will cancel out. After cancelling, what exactly we are getting? The equation P1 rho g plus Z1 P2 by rho g plus Z2 plus H. So we have to find out H from this equation, right? Now what we have given, we just need to find H, so we can simplify this equation further. How we can simplify? Just write it down here. P1 by rho g plus Z1 P2 by rho g minus Z2, sorry, it's definitely minus, is equal to H. Now we can get common 1 by rho g, and here P1 minus P2 plus Z1 minus Z2 is equal to H. Further we can write P1 is 50 kilopascal 10 to the power minus 3, and P2 is 20 kilopascal 20 into 10 to the power 3, and then rho is 1000, 9.181 is G, plus Z1 is 10, Z2 is 12, is equal to H. Alright, now this will become what? Minus 2. Okay, and after calculation, and this minus 2 will get the value of H. So what we require basically to solve this kind of problem, that is the approach. First we need to have approach to solve the problem. Second, we need to draw a diagram related to it, just like we have done here, right? So after doing this, we can easily find out its problem. Okay, but yes, the formula we also require to find out the equation. But if you started about Bernoulli's equation only, then probably you will not see this H, right? So if you have gone through few questions related to it, then only you can able to see this H. I mean, then only you can to analyze that yes, you can also find out head loss by using Bernoulli's equation. Okay, so this is all about it. Now we just required calculator. After calculation, we can find out the answer. So let's go for it. Okay, now think about this. I mean, just simple calculation we can do without calculator. This one and this one get cancelled. Now 50 minus 20 would be 30 divided 9.81 minus 2 is the head loss, right? So so what is the value? 30 divided 9.81 30 divided 9.81 is this minus 2. So what exactly value is getting? H is equal to 1.058. that means if we compare with the answer, it should be 1.06. now we have two options here. One is head loss, and both are same, but yes, definitely head loss will be taking place from S1 to S2, because this is the elevation, because of this elevation. So the answer for this question is A is the right answer. Now most important, which I haven't shared with you, or I must say I haven't put a lot of focus on that. That is a unit problem, because most of the time what happen, we just skip this 10 to the power cube. Because of this skip, we got wrong answer. So don't skip this 10 to the power cube. So how to get this all the 10 to the power cube values? That is, try to see what unit you need to find out in the numerical problem, then see what unit they have given. Pascals means Newton per meter square, and kilo means 10 to the power 3. So always focus on, and of course don't repeat this unit mistake. In my all of the numerical problems I shared that unit is one of the biggest thing to find out numerical problem with maintaining accuracy. So don't do that, try to maintain unit accuracy. So this is all about head loss using Bernoulli's equation. Thanks for watching. See you soon in my next video. Bye bye. Ujjwal Kumar Sen, and in this video tutorial we are going to talk about head loss because of friction. Alright, so basically what is head loss and why it is happening? That's because of friction only, right? So head loss basically, resistance to flow of fluid through pipe, and the resistance, because of the resistance there is loss in the head, it is known as head loss. I mean the fluid flow will not go to that part, I mean that portion because of friction. So that loss is known as head loss. Okay, let me share with you. I mean, suppose that you are going, I mean, this is something is going this side, right? And some body you can say. And if without friction the body will reach here, that's because of friction the body will reach here only. So there is a loss from here to here distance. The same case in case of fluid. If the fluid is flowing through pipe, because of loss the fluid will flow to till here, not till here. So this loss is known as head loss basically. So now this why I'm basically sharing this topic, because on this topic in GATE they have asked question 2 times from, I mean, related to this topic only. Okay, so this topic is, I mean, 2 to 3 times basically. So this topic is really important for you. Alright, now how to find out head loss first of all. So if we'll go through different books, different books denote head loss by different unit. But I will tell you understand head loss or remember head loss because of friction with HF, small and HF. To find out at head loss because of friction, there is a formula, that is FL V square by 2GD. This is a simple formula we have to find out head loss of a pipe through, I mean, because of the fluid is flowing through it, right? Now here you will understand all things. First of all, we need to understand what are things we are using here. What is F, what is L, what is V, what is Z. Yeah, this one you know, I know that. This is acceleration due to gravity. In SI it's 9.81 meter per second square. One more thing, don't forget to understand unit of anything. Okay, this is known as friction. This friction is not having unit, right? And D is diameter of the pipe, you can say, through which the fluid is flowing. Okay, now L is length of the pipe. Why I am sharing with you all this? Because you will understand, either you will read theory or you will understand. Those I have already did. That's why I am creating these videos. I want you to understand each and everything within a short period of time. That's why I am creating all these videos effectively for you guys. Now, what is this V? V is velocity. V is velocity, right? Velocity is in meter per second, diameter definitely in meter. Okay, and this is unitless, length definitely in meter. Alright, now velocity. So how, I mean, you can get confused only in case of velocity, because most of the question they will not give you velocity. What is the value of velocity directly? Never. They will not give you. They will try to make relation with another thing that is known as discharge, which is denoted by Q. Somebody tell small q, somebody tell capital Q. That is depend on you, what in which you are familiar. Okay, so basically Q is equal to VA. We know that. Okay, now the unit of Q is meter per second, and VA meter, velocity meter per second, area meter square. So from this relation Q is equal to VA, you can find out velocity. Again, area, most of the question I have seen, they have used circular cross section. That means area pi by 4 multiple d square. So these are things you require to solve problems related to this head loss because of friction. Alright, so in this in the first half of this video, I have shared with you how to formulas related to it, how to find out the question basically with little basic concept. Alright, now let's go for the numerical problem which I wanted to share with you. Yeah, the numerical problem is right now in front of you. So the thing is that you need to learn how to find out, how to solve this numerical problem. So first of all, read the problem. Well flows through a 200 diameter horizontal cast iron pipe. Friction is this, of length this. Volumetric flow rate, that is Q, meter cube per second. Head loss due to friction. So what we have to find out? We have to find out, basically find head loss. We have to find out HF is equal to what. So I have already shared with you the formula for HF is equal to what? That is FLV square by 2GD. Okay, now put all values we have given in this question. G is 9.81, diameter is 200 that means 0.2. okay, it's 200 and here all values we are getting, they have told us to find out in meter, that means SI. So we have to convert all unit into SI while solving the problem, otherwise we will solve the problem but will not get the right answer. So F is 0.0225, L is what, 500, and VE, we don't know what is the value of V, but yes, we can find out. So we know that Q is equal to VA. Now V is equal to Q by A. I have already shared with you what are these things, that's why I don't need to repeat. Now what is Q we have given, that is 0.2. Now area pi by 4 d square 0.2 square. Now we need to use calculator to get accurate value. Okay, it's pi divided by 4 multiple 0.2 square. So 0.2 divided answer is how much we are getting, 6.3661 meter per second square, right? This value we are getting. Now 6.366 square, right? Square is here, multiple 500 multiple 0.0225 division 2 multiple 9.81 multiple 0.2. So we are getting here values 116.19 meter. Now make just check the answer with yeah C is the right answer for this question. So what things we have basically used to find out answer of this question? First of all, you need to be familiar with online calculator. Why I am sharing with you online calculator? Because online calculator is not like this one. Yes, this one is handy and probably you have practiced with this calculator. So you need to understand all function of online calculator, and don't try to calculate all things together by using that calculator, because you are not familiar. So probably you can make mistake while doing calculation. So I will suggest you practice with that calculator. That would be quite helpful for you. Alright, now let's go for something new related to it. Now suppose that you have learned this is simple, right? Head loss because of friction. You have to understand it's beyond concept, just like how to find out power. They have asked question related to it. Well, I have already shared with you question also related to it. Probably if you have watched that video, then that's really fine. That's really good. You have learned another question, but you haven't watched. I will suggest you to watch that video, and definitely that video will help you to understand its basic concept, as well as to learn another thing about this video. About this topic, flow through pipes. Okay, now. So let me share with you formulas related to it. Basically, we have to find out, in that question they have asked to find out pumping power, that is P is equal to rho G Q HF. Okay. So basically this formula we can use to find out pumping power, and they have given all things, but yeah, in this question also we can get these three things quite easily. Okay, but this density, this is density they have given separately. If they have asked a question, they have asked to find out question related to pumping power or power in case of flow through pipes. Okay, so this is all about this tutorial. Thanks for watching. See you soon in my next video. Bye bye. My dear, so this is Ujjwal Kumar Sen, and in this video tutorial I'm going to share with you how to find out pumping power required. Well, this I'm talking about flow through pipes in fluid mechanics, right? So pumping power required, to find out this, why I'm sharing with you, basically I'm sharing with you this topic because from this topic in GATE they have as question. So how to find out basically pumping power required? Okay, so basically we know that the basic formula for pumping power required, let's say power is equal to P is equal to rho G Q H F. Okay, so what is rho? Basically rho is density, G is acceleration due to gravity, Q is discharge, and HF is head loss. Okay, now most important thing is that to find out pumping power required, you need to know all these terms. So in the examination they will ask you question. I have gone through few question, more than 10 even in this topic only. So in most of the question they have given density, Q, G is not required to give. Q also they have given. If they did not give, I will tell you how to find out Q. But in most of the question they did not give HF. How to find out HF? They did not give direct value for HF. So you need to know how to find out HF in order to find out pumping power required. So the relation they can make to make the question little tough in these three: density, Q discharge, HF is head loss. Okay, so to solve problems related to this topic you need to know further formulas of these three things. Okay, so I'm going to share with you what are formulas. Density is mass by volume. Okay, so volume here they can give you anything. They can give you any shape, so you need to know how to find out volume. Okay, first. Second, discharge A1 B1 or AV. Here V is not volume, here V is velocity, and its density is kg per meter cube, its unit, right? G we know that 9.81 meter per second square. Unit of Q is meter cube per second, that is discharge. Okay, now head loss is required. To find out head loss you need to know few things. So because head loss formula HF equal to FL V square by 2GD. This is the formula for finding out HF. So FLV square by 2GD. So here you may get problem. You know what is that? Because in the question probably they will give you discharge. So discharge is something meter cube per second, and they will give you diameter of that cross section, and most probably they will give you circular cross section, just like here they will give you diameter of this circular cross section, suppose that 100 mm. Now what we have to do, basically we have to find out velocity for this, for finding out head loss. So for finding out velocity, what we have to do, velocity is equal to discharge by area of that cross section. Now look at its unit, meter cube per second divided by meter square. So this is cancelled, so what will be remaining? Meter per second, that is the unit of velocity, right? So this is how you can relate. That's why I'm sharing with you all this, because this is required to solve the numerical problems. Well, this is all about all formulas I have shared with you to find out pumping power required. Now in the next part of this video I'm going to share with you that numerical problem, yes, which has been asked in GATE previous year. That's why you will have an approach to solve problems related to it. I'm sure these formulas will help you a lot to solve that problem. So what are we waiting for? Are you ready to go for, of course you are ready to learn that numerical problem, right? So let's go for it. Now here in front of you right now a question is here. And in this question we have given, when this is the question they have asked in GATE, right? So let's read the question first. Water at 25 degrees centigrade is flowing through at 1 kilometer long pipe. So from here we can write all those datas. Okay, so if you are beginner, then first read the question, then solve. If you know formulas and a little bit you have experience to solve numerical problems related to this topic or any topic, then just find out what you need to find out. So to find out what you need to find out, just read. I did analysis of more than 90% questions. That if you wanted to know what to find out, just read last line of the question or first line of the question. Now in this question, if we'll read last line of the question, then what you find? Pumping power required. Again, the unit they have given, so don't forget to keep in mind this unit, because without unit you cannot solve the question right way. So the unit is kilowatt, right? Pumping power required to maintain flow is this. Okay, now what we have given, length is given, this is given, that is given. Okay, no problem. Now what we have to do, we have to first write power is equal to rho g hf into q. You can say this. Now we will see what they have given in this question directly. So density they have given, yeah, they have density given, that is 1000. Okay, g don't need to see. hf, head loss they have given, I don't think so they have given, but q I have to see, as q they have given 0.07 meter cube. Now if anyhow we can able to find out value of hf, that is head loss, then we can easily find out power required, right? And one more thing, keep calculator with you. So one suggestion for you, if you are just watching this video, then you will understand how to solve the problem. Okay, but if you will keep working, just get pen and copy and start writing what question I am giving in this video tutorial. Just write that question and solve yourself, then only you will understand how to solve. You will have approach, and definitely your concept will build up, that is required to solve numerical problems. Okay, now this is hf is here. So what is hf, how to find out basically hf, that we need to understand, that is flv square by 2gd. Now what is f friction? They have given friction, friction factor, that is given 0.02. okay, now L, length of that 1 kilometer, that means 1000 meter. Unit play most important role, remember that. Now 2g 9.81. D they have given, yes, it's 0.2 because 200 mm is there. Now we need to find out velocity. Anyhow we can find out velocity, then we can find out hf. Are you getting my point? How these things are interrelated with each other? That's why I have already shared with you how to find out things. Okay, what things we have to find out in this question. All right, now what we have to find out is velocity. Velocity is what? q by a. I have already shared with you. Q is 0.07, a is pi by 4 d square 0.2 square. So if we'll find out this value, then we have to just put this value and square. Here again you will make mistake, will just forget this square, so don't forget this square. Okay, now just find out this pi by 4, okay, multiple 0.2 square. Alright, 0.07 divide this, okay, it's square, so it is 4.9647, it's square, multiple 1000 multiple 0.2 division 2 multiple 0.2 multiple 9.81. so the answer we are getting here, that is 125 I'm getting here. Probably there is some mistake I am doing. Okay, let's check it. Let me just check it out, then I will share with you. Okay, yeah, so basically what exactly we do is just we do square already this. So after squaring we are getting this value 0.49647, right? Now So 4.4, it's 4.9647 multiple 1000 multiple 0.02 division 2 multiple 0.2 multiple 9.81 is equal to, this is, we are getting here 25.30 HF in meter. Head loss, this should be in meter. So we have find out that value of HF. So we just need to put this value here, 25.30. Now just do multiplication, 1000 9.81.07 multiple 25.3. okay, so we are getting here 17373.51, because they have asked to find out value in kilowatts, so I have to divide by 1000. So 17.37 kilowatt is the answer. Now we have to check out which one this answer is matching. Okay, we can easily, 17.4 is here, so option D is the right answer for this question. So this is how we can solve question related to it and related to this topic. Thanks for watching. See you soon in my next video. Bye bye. So this is Ujjwal Kumar Sen, and today's topic is concept of discharge. In GATE they have asked question related to this topic, and almost everybody know what is discharge basically. Okay, suppose that this is a pipe and fluid is flowing through this pipe, right? And the velocity per unit cross sectional area is known as discharge. It is, we also know by we denote it is by Q. Therefore, if you will see unit, velocity unit is meter per second, unit of area is meter square, so units become meter cube per second. Now there is a simple concept, that is a concept of pipe. If you have studied flow through pipes in fluid mechanics, then definitely you know about this concept, right? That is pipe 1, pipe 2 and pipe 3. That there could be any number of pipes, right? So if we'll find out, it's simple concept, right? So Q1 plus Q2 is equal to Q3. I mean discharge from pipe 1, discharge from pipe 2 is equal to discharge from pipe 3. If you will neglect friction loss, if you will consider friction loss, then we cannot apply, because we don't know how much energy will be, how much head loss will be taking place here and here and here. So we have to neglect that to validate this equation, Q1 plus Q2 is equal to Q3. Actually, based on this concept of discharge, there is a question they have asked in GATE previous year, and because of that I am creating this video tutorial. Okay, so this is all about discharge and its unit and its formula also. Therefore we know that Q is equal to V1 A1. Okay, if we'll say Q1 is equal to V1 A1, Q2 is equal to V2 A2 and Q3 is equal to V3 A3. Okay, this is a simple formula. Q is equal to VA. That's why there are many, maybe you have seen this, A1 V1 is equal to A2 V2 in continuity equation if the fluid is incompressible. Okay, if it is compressible, then rho 1 A1 V1 is equal to rho 2 A2 V2. So these formulas probably you have gone through if you are preparing for GATE like examination, right? Now let's go for that numerical problem, which numerical problem asked in GATE previous year. That's why you can understand much better. I will come back to this topic, that how to prepare this topic flow through pipes, because most of the time they have asked question in GATE previous year I have seen, and it's really simple to solve question related to this topic. Okay, I will talk on this topic, okay, because I have to first share with you how to solve the question. So let's go for it. So in this question, if you can see the whole screen right now with the question only. If you read this question, then probably it will take 2 to 3 minutes. Okay, so let's read the question first, then I will share with you how to solve it. Okay, and I have already shared with you formulas we are going to use in this numerical problem to solve this. Okay, let's go for it. Consider steady flow of water in a situation where two pipelines, pipe 1 and pipe 2, combined into a single pipeline. It's okay. Pipeline 3 as shown below. This is below, and cross-sectional area of the pipelines are constant. Okay, flowing data as given. So data I haven't written because of space I do not have, but yeah, its area is 1 and coefficient of discharge is 1. Okay, sorry, its area is 1 meter square and its velocity is 1 meter per second. For pipe 2, its area is 2 meters square and velocity is 2 meter per second. And for pipe 3, they have given area is 2.5 meters square. Okay, these data they have given in this question. Now what they said, assuming water properties and velocities to be uniform uniform across the cross section of the inlets and outlet. So exit velocity in pipe 3 is, that means we have to find out velocity here. What is the velocity of the fluid following through it at the exit of this? Okay, so this is a simple formula we can implement, but as you have gone through, it's required lot of patience to read such a lengthy question. So after just seeing this diagram, we can say that what we have to find out. Okay, the data given in the question, that is must to understand, right? So from this diagram, what exactly I have shared with you, the same diagram they have given in the numerical problem. So we have to use this formula here, right? So what is the formula? Basically q1 plus q2 is equal to q3. Okay, that means discharge at pipe 1, discharge at pipe 1, discharge at pipe 2, and discharge at pipe 3. Okay, again we know that q1 is equal to a1 v1 plus q2 is equal to a2 v2, q3 is equal to a3 v3. I have already shared with you this formula. Okay, now we know a1 is 1, v1 is 1. Okay, again we know a2 is equal to 2 and v2 is equal to 2. Again we know a3 is 2.5, but we have to find out v3, that is v3 we have to find out, right? Now thing is that most of the time where exactly we are going to make mistake, that is a mistake of unit. We'll not look at unit. So before going to solve the numerical problem, we have to look at the unit, what units they have given in the numerical problem. Then we must go for solving it, right? So what are units basically given in this question? You can see meter, meter per second, meter per second, meter, because these three things are, these 2 to 4 5 things I am using in this equation. So I have to look at these 5 things only. Okay, these units are in a single unit system or not, then I will go for solving the question. So this is how this is about this is about gate. If you are preparing for gate, you must understand all unit system. If you will not understand all unit system and the units, you have to be get in one unit system all unit. Okay, then only you can get right answer. Otherwise after knowing even everything, you will make mistake. So don't try to repeat that mistake. That's why in my almost all videos I talk about it, that don't make mistake in unit, because unit play most important role. That is the thing. So here 1 multiple 1, 2 multiple to 4 is equal to 2.5 multiple v3. Even we don't require calculator. Okay, so 1 plus 4 5 is equal to 2.5 v3. Therefore v3 is equal to 5 by 2.5 is equal to 2, because all unit are in SI, and therefore velocity, unit of velocity in SI is meter per second. Okay, so answer is 2 meter per second. Now look at the options we have given in this question. So the answer we got is matching with option B. Okay, so without any doubt you can mark the right answer of this question. And could you believe this question asked in GATE previous year, and the question was of the question asked in 2009, and the question was of 2 marks. Okay, as I am sharing with you this question, telling you each and everything about the question, the formulas we have used, and of course I am talking about how you will not make mistake. Even then I am taking only approximately 7-8 minutes to solve this question. But yeah, while you will sitting in the examination and you know all these formulas, then I don't think so it will take more than 2 minutes or 3 minutes. I mean, time will take here only, right, to solve this part. So you don't need to write in details in the competition examination, right, because you just need to find out the right answer. So but one more thing, if you're a beginner or you are not familiar with formulas, then try to write in details. That's why you will not make mistake. Otherwise I have seen most of the time even I have seen my students make mistake because of in hurry, they are in hurry, that's why. So let's preview again it's all things. So what we have stated here is concept of discharge. All right, so in this case what we have to understand that discharge inlet is equal to outlet, that is q1 plus q2 is equal to q3. This is the most important concept to understand in this case. Okay, now the simple formula for discharge and its unit system we also need to understand. Okay, now most important, we need to also understand continuity equation, that is a1 v1 is equal to a2 v2, but that is valid only for incompressible fluid. Okay, so this is all about concept of discharge. I hope you understand a new concept and you can solve this type of problem in the upcoming competitive examination. Thanks for watching. See you soon in my next video. Bye bye. Hey dear, this is Ujjwal Kumar Sen, and in this video tutorial I am going to share with you how to derive Bernoulli's equation, right? So probably this tutorial would be quite lengthy, but yes, yeah, this is really going to help you to understand about it. So let's get started. Okay, so first of all, I am assuming few things, just like delta A is cross sectional area, and u, I must say u is fluid velocity. And of course another thing that is assuming, that is we are going to derive this equation with stream wise direction, and we are considering it as k. Okay, so these things we are assuming here in this derivation. Now we'll go for the diagram, which is really important for the derivation point of view. Okay, and this is its center line. Suppose that fluid is flowing through this, right, through this pipe, you may say that. So let's say this is theta, and okay, A, B and C, this are triangles. Let's say this is u, fluid velocity u, and this side u plus du by dk into delta k. Okay, so and this one is delta k, this is delta z. So these things you need to remember for this derivation, right? Now what exactly we know one simple thing. Okay, that is pressure is equal to force by area, right? First simple formula we are going to use in this derivation only. One is density is equal to mass by volume. We will also use this formula. And of course another thing we will use, that is integration. So three most important and basic things we are going to use in this derivation. I hope you understand this, right? Now let's go for it. So if we can say that for pressure is equal to force by area, then we can say force is equal to pressure multiple area, isn't that? So this is like simple. Now what we can say, net force F is equal to pressure delta A, cross sectional area we have already considered, minus P plus dP by dk into delta k multiple delta a minus mg sine theta. Okay, so one thing I would like to share with you, if you remember this, and then things done. I mean, you don't need to don't need to be don't need to be create any problem, anything. Just remember this equation, and this is really simple to remember, right? Now do little bit simplification. P delta a, I'll multiply this P delta a minus dp by dk delta k into delta a minus mg sine theta. So this one get cancelled. So what we got, minus dp by dk delta k multiple delta a minus mg sine theta. So this is the equation we got from here. Now what we know, basically I have already shared with you, density is equal to mass by volume. So we can say mass is equal to density into volume. So density is rho and volume is stream delta k multiple area, cross sectional area. Okay, now we know another thing, acceleration is equal to velocity divided by time. Therefore velocity is what here, u du by dk multiple delta k minus u divided by delta t, time. Now just do calculation. This one and this one get cancelled. So what we got, du by dk multiple delta k by delta t. So what we can write from here, that is u multiple du by dk. So this is the thing we can write from here, because what is u, basically because u is equal to d it's du by dk, so dk by dt. This is u, fluid velocity, stream, its k is stream wise direction stream, and this is time. So distance by time is known as, displacement by time is known as velocity. So this is about u, right? So what we got from here, we got mass, we got acceleration. Okay, so these two things we got from here. Now let's use another basic thing, that is Newton's second law. So what Newton's second law tells us, that force is equal to mass into acceleration. We know that force is equal to mass into acceleration, and mass, what we have used here, mass, that is density delta k multiple delta a, acceleration u du by dk, we have used this. Okay, du by dk. Now what is force we got from that equation? Okay, let me share with you. This is force we got from this equation. Force is this, so we have to just write it down here. Okay, so what we got, basically dp by dk delta k delta it's da it's delta k dp by dk delta k da, I must say that. So da minus mg multiple delta rho delta k delta a g sine theta. We have written all these, right? So this is all about this equation, right? So I hope you understand it, right? So let's go for the next step, that is here only. Now actually what exactly doing we have, that is mass into mg. What is mg? Basically we have already written what is mg here, mg. Okay, so mg, g is here, m, what is m? Basically m is mass, so we can say density is equal to mass by volume, and mass is equal to density into volume. So it is density, volume is here. So in place of mg we can write this one. So if I will simplify this, what I can write, basically that is also important, that is minus dp by dk delta k delta a, okay, and minus rho delta k delta a into g, it should be delta a, right, into g multiple sine theta is equal to rho delta k delta a u du by dk. Okay, got it? So till now what we have done, we have just done simplification. Okay, now from this triangle, let's see this triangle ABC. So from triangle ABC, what we can say, sine theta is equal to p by h. So p by h means here p is CB by CA. Okay, so CB is delta Z and CA is delta K. So here in place of sine theta, what we can write basically, delta Z by delta K. This is the thing we can write here. Okay, now what we have to do basically, that is also important. So what is that? Let me share with you. Okay, so what's that? Let me share with you. So what we'll do, we'll just put this value first here and do little simplification. So minus dp by dk delta k delta a minus rho delta k delta a g delta z delta k rho is equal to rho delta k delta a u du by dk. Now we'll do just division, all members on both sides we will divide, both side we will divide by delta k and delta a. So what we'll get, minus dp by dk minus rho g delta z by, sorry, delta z with this no, it's delta z, we can write that dz by dk, right, is equal to rho, it's this will cancel, so rho u du by dk. Is this simple? This is really simple, right? Now what we can do basically, we can send this number to this side. So what will happen, dp by dk plus rho g dz by dk is equal to plus rho u du by dk is equal to 0. If we'll do little simplification here, then this is known as Euler's equation, and if we'll do little simplification here, then this is known as Euler equation. Okay, now simple, we will, after integration of this equation is known as Bernoulli's equation. You just need to integrate this and do little bit simplification, then what will happen, this equation become Bernoulli's equation. So that is the interesting part, right? So let's go for it. Do integration first. So what exactly we are going to do, we are going to do integration here, that is dp by dk plus rho g dz by dk plus rho u du by dk is equal to 0. So after integration, what we'll get, p plus rho g z plus rho u square by 2 is equal to c. Okay, now exactly one thing I have to do, that is, before this integration I can divide. Okay, after the integration we can do, because this is constant. Okay, there is no values of this constant, so we can do anything with this, because this constant having any number of values, and this is also known as arbitrary constant, right? So we have to divide this number, whole number, by rho z. So what we get, p by rho g plus u square by 2g, rho get cancel, plus z is equal to constant. And as you know, this is known as Bernoulli's equation. I hope you understand each and everything of this equation, and probably after watching this video you will not face any problem to derive Bernoulli's equation. Well, thanks for watching. See you soon in my next video. Bye bye.